So it's
946,
940.
sir.
Sir,
It's a 46, 47.
946.
Okay, fine. So we have another 10-15 minutes. That's good. Yeah, now we could able to see the slides.
Yes, sir.
Okay. So up to the previous class, we were discussing about how to calculate the bearing capacity of a footing. Now today, let us take the part B of the shallow foundations, that is calculation of the settlement. So this part also, in brief, we
sir,
discuss. Yeah,
sir, sir, in assignment, sir, there was some questions that was not taught actually, some two questions.
yeah. One question on the settlement. That question you can leave it. One or two questions on settlement. So that can be solved after completion of this chapter, this part B. Okay, so yeah, so settlement. In brief, we did discuss about what is settlement. Suppose if you apply any overburden pressure on an in situ soil, as shown here. So in situ soil. So one can able to anticipate three variety of settlement patterns. One is the uniform settlement as shown here. Next is differential settlement, where there is a difference in intensity of the settlement at both edges or between the two footings. So there is a differential settlement means if that differential settlement exceeds some value, then there is an inherent danger to the footing. Or alternatively, that differential settlement can also be used to calculate another parameter that is called as the angular distortion. As you can see here, the angular distortion theta is defined as difference in settlement for a footing between the two outer edges and between and to the distance between two footings. So the S is distance between the two footings and theta d is the angular the differential settlement delta d. But among these three settlement patterns, so as long as the uniform settlement is, or as long as the footing is settling uniformly, so there is no inherent danger to the foundation system. It is only the differential settlement or the angular distortion that causes a kind of uh, possibility of the collapse of the structure. So therefore, one has to address critically the differential settlement and angular distortion. But at the same time, we should also need to calculate the amount of the total settlement. So that cannot be ignored. So these are the sources for settlement. The first is, suppose if you take the soil and the foundation two as an independent system, the soil itself can undergo the consolidation, or the again here if you take the soil, there are two things: grain as an individual, the soil as a whole. The grain as an individual can undergo the compression, that is called as the elastic compression of the soil grain or the elastic compression of the foundation, and the soil as a whole can again undergo the elastic compression or the plastic compression depending upon the soil type. For example, if it is a sand, so there is no consolidation phenomenon that can happen. But if you take the clayey soil, so this soil purely undergoes the consolidation. So therefore, if the soil is a sandy type, elastic settlement or elastic compression of the grains is predominant. If the soil is of clay type, then one can able to anticipate the primary and secondary consolidation. So these two you have very well understood during your soil mechanics. I don't need to repeat. Another important source for settlement is fluctuation in the groundwater table. So this is in terms of, if you look at the formula of sigma dash is equal to sigma minus u, the increase or decrease in the pore water pressure in the form of a groundwater table change causes change in the effective stress. So when there is an increase in the effective stress, there is increase in the settlement. So these are the three fundamental causes. So there are secondary causes also. For example, the building was already built, but adjacent to it some kind of a construction activity going on in the form of a pile driving or a blasting or oscillating mission, so on and so forth. So depending upon the soil type again, so such secondary actions might accentuate the settlement and could become one of the source for the settlement. There are a particular soil types, those are called as a expansive soil types. So these expansive soils has an affinity to imbibe significant amount of water. Whenever soil absorbs or takes lot of water, it inherently shows two phenomena. Those are called as the volume change, increase in volume referred to as a swelling, and decrease in volume referred to as shrinkage. So you can understand, if the soil is absorbing the water means volume is increasing. So this can be correlated with your one of the soil mechanics experiment, that is consistency limits. When you have performed consistency limits, you did not change the volume of the soil. So you have only keep on adding the water content, and as a result you also noted down how much would be the increase in volume. So for example, you have seen shrinkage limit, plastic limit, liquid limit, so on and so forth. So all these indicate the increase in water content leading to the increase in overall soil volume. There are other causes also, like surface erosion. So because of the erosion, the footing gets exposed. Creep, you also aware, creep means a permanent settlement to the structure even without increasing the stress. So for the same stress, a constant settlement. So landslides in earth slopes, this is an artificial phenomenon, landslide, and other miscellaneous such as collapsible soils, mining subsidence, underground erosion, earthquakes, adjacent edge connections, all these are the secondary. So they could also become one of the sources for the settlement. One of the best example of miscellaneous is, if you look at in the internet, there are something called as a sinkholes. So sinkholes are very famous, especially in Gulf countries, where the formation of the sinkhole happens because of the leaching of calcium salts from the soil. Whenever there is a leaching of calcium salt, it leads to creation of some kind of the void, so which increases the void ratio. More is the void ratio, more is the settlement. So these are a couple of the sources for the settlement of the footing, so that we can able to understand. So then so we also know, if somebody is asking you to calculate the settlement of a footing, so they may ask you to calculate for two fundamental things. One is what would be the immediate settlement or the elastic settlement, and what would be the consolidation settlement. Elastic settlement means, so it is the settlement that takes place immediately after the construction of the structure. So there is no, it is not a function of the time. It happens within couple of months of the post construction of any structure. Okay, so this could happen both in clayey type of the soil and sandy type of the soil. However, the elastic settlement is predominant in sand, very minimal in clayey soils. Now the opposite of the elastic settlement, or the completely another phenomenon, is consolidation settlement. So again, you have undergone the theory of Terzaghi's theory of consolidation during your soil mechanics course. I don't need to repeat it. The consolidation phenomenon is typically valid only for the clayey type of the soil. So these clayey soils, they hold the water due to the diffused double layer, and this diffused double layer water gets released when you increase the stress on the soil. So in case of the elastic settlement, The settlement is primarily because of the compression of the grains. Compression of the grains. The compression of the grains could happen immediately after the load. While on the other hand, the consolidation settlement is a time-bound phenomenon. So as you know, the consolidation can be defined as the reduction in the volume due to expulsion of water from the voids. Expulsion of water from the voids. So that means nothing to do with the soil grains. It is something to do with the water. As water gets expelled out from the soil sample, the reduction in the volume or that place is occupied with the soil particles, meaning thereby as water gets expelled out from the soil, there is a readjustment in the soil particles. So that will be referred to as the consolidation settlement. But since the expulsion of water occurs with the permeability of that particular soil, and the permeability of the clay is so low, so therefore it takes immense amount of time for consolidation to happen. So in a summary, the elastic or immediate settlement can happen immediately applying the load, especially in sand or predominantly in sand, but in a small magnitude in clayey type of the soils. Consolidation settlement, they cannot occur in sandy soils. They are predominant only in clayey soils. However, the consolidation settlements are time bound. So they can occur over a period of longer time, like 1 year, 2 years, 3 years, 4 years, 5 years, so on and so forth. So this is the total settlement. Your total settlement is nothing but immediate settlement plus consolidation settlement plus the secondary settlement. Okay, and these are some causes for the settlement. So the we already discussed about all of these things. There are some more things also, like there are thermal changes, subsidence, everything. Thermal changes we did not discuss, but otherwise all the causes we have discussed it. So whenever you talk about the total settlement of a footing, it is summation of the immediate settlement plus consolidation settlement plus secondary settlement. But in this chapter, we will discuss about the immediate settlement and consolidation settlement. So I will stop it here. Maybe we can discuss, or we, actually this is a very small chapter. We can able to finish it up by next class.